So let's talk about what this card basically means. Yes, ma'am. Go ahead. All right. So we know f prime, and f double prime. These are the slope function of each other, correct? Or the derivative of each other. The PVA basically means the original function is the position, the f prime is the velocity, and f double prime is the acceleration. All right? So go ahead and write that on the side. And I think I'm going to also write them on the very top. So we have position, velocity, and acceleration. There's a little net in here. Oh, goodness. Okay, let's write out. So we have F is for our position. Even though it's already on our card, I want to kind of notate something else. And our position typically it's either going horizontally, which would be denoted with x of t. If it's going vertically, what would that be denoted with? Y of t, and whatever else it wants to be. And it could even be s of t. It could be v of t. Well, I guess not v for this one. So we have f prime is going to be for the velocity. And for my velocity, I want to mainly focus on just one notation to be consistent. Okay, the velocity will initially be notated as v of t, but what I can do is the following. If f and f prime is a situation, I can say s of t is the same thing as s prime of t for velocity. Do y'all see the pattern on here? F to f prime, s to s prime. Good? So then let's go on to our double prime, and that is our acceleration. And acceleration is denoted with a of t. But I could say the following instead. If I have f to f prime to double prime, I could say s single prime to what on this one? Double prime. Or someone creative could go, well, you know what? I don't want to look at it from s. Could I call the a of t v single prime? Because if I derive the velocity, it is the acceleration. So it really depends on which one are you going back to. All right? So I'm going to kind of go in that order, depending on what question, but not on every single one of them.
What letter is that?
Which one?
The one that's like the double prime?
Double prime, that should be an S. It looks like an A, right? That looks nothing like an S. Is that U? Is it A? Yep, I think I wrote an A. So that was S. And Xavier wants to take credit for that, right? I'll take it. I'll write it down. If I forget, you let me know. Because it did look like an A. All right. So now let's talk about what the following blanks are referring to. And on the blanks, I'm not going to go over all of them. So if you want to fill it in, go for it. I don't want to. When something is at rest, that means our slope is at 0. And our slope in this case is referred to as velocity. And then going back to my card, if the velocity of the particle is positive, so if it is positive, and I forgot to read this part right here. If x of t represents the position in a particle along the x-axis. If something is going along the x-axis, is it going up and down at all? No, it's only going left to right. So in this case, if the velocity of the particle is positive, do we all see positive? Then the particle is not going up. But for in our case, since it's x of t, it is going to the right. And on the bottom, the particle is moving to the left. That will be considered moving to the left if the velocity is what kind of sign? Negative. And then the next two is pretty much review from unit 1. So let's see what that means. To find the average velocity, let's go ahead and underline the average. Y'all remember the acronym AROC? Okay, average velocity. It's a change, or you divide that into the change in position. And by that, what I mean by is a slope formula. So if I say f of b minus f of a over b minus a, simply the slope formula. So if I have on the next one instantaneous velocity, what was the acronym that we used if the one above is AROC? IROC. And to find the IROC is simply the derivative. And just to kind of recall from what we did talk about before the break, if A rock and I rock are equivalent, what value theorem are we looking at? Mean value theorem. We are going to use this eventually, so I'm just kind of giving you guys a little reminder. All right, so going back to our PVA card, if the acceleration of the particle is positive, so go to our acceleration, go over to the row where it's got positive, then what is going to be increasing? F prime, which is velocity. And then our next one, it says the acceleration of the particle is doing something when the velocity is decreasing. So go to velocity. It is decreasing. What is the acceleration doing? It is negative. And our very last one on the bottom. So for the particle to change direction, so here's my particle, is changing direction. What is happening to my velocity? It is also changing signs. So in case you might have forgotten the derivative, let's practice that real quick. So position is the original function. Velocity is our f prime. And acceleration is our f double prime. Let me zoom in. If you're looking at x of t or y of t, it doesn't really matter. But I just want to use this one just because we're in the x of t for this page. So for the velocity, let's find the derivative. What is the derivative of my first component? T what? T squared. And then my second component is minus 2t. And minus what? Minus 3. What else could I have denoted instead of v of t for this one if it's originated from x of t? I could say x prime of t. So if you give me this one or that one, it just means the same thing, but I'm just alternating back and forth so we kind of get in the groove of it. For the acceleration, let's write a of t. Let's also write on this one, this is v prime of t, which is x double prime of t as well. There's 3 different notation. You pick whichever one you're comfortable with. Now let's find the derivative of the velocity. We have 2 what? Minus 2. Was it 2? Yeah. All right, let's go on to the next page and do some application problems. Okay, on this page, 2 things that we are going to use from the previous, the mean value theorem, and then where was our intermediate value theorem? There it is. The intermediate value theorem. So if you want to look at that card, cool. If not, I have it on the board. I'll leave it on for about 5 seconds. Oh God, it's hot. Even with the fan. Okay. All right, Milo, go ahead and read example number 1 on the top. It's above the chart.
The data in the table below give the selected values for the velocity and meters per minute of a particle moving along the x-axis. The velocity is a differentiable function of time.
So it's moving along the x-axis. Our answer is going to be left or right. And when something is differentiable, it is also what? Continuous. So let's analyze what it's asking us for. First of all, we have our independent value is t. Dependent is the velocity, not the particle or the acceleration. So at t equals 0, so let's circle t equals 0. Is the particle moving to the right or the left? So just by looking at this, let's write out v of 0 is equal to negative 3. And let's see what we have on the card. If the velocity is negative, the particle is going to the left or the right. Now, the way we're reading this is the following. When it's going up, it's considered going to the right. When it's going down, it's considered going to the left. So it's going to the left. So let's write left. Because v of 0 is negative. Cody, pick up the packet, please. All right, for number 2. Alan, go to read number 2, please.
Is there a time during the time interval 0 is less than or equal to t, less than or equal to 12 minutes when the particle is at rest?
So the particle is at rest. So we know that means our velocity must be 0. You could also say the slope must be equal to 0. They mean the exact same thing. Because the velocity is a slope function of the particle. So in this case, let's analyze our velocity. And let me change my pen real quick. So looking at my velocity right here, we know this has to be a continuous function. Where must the 0 lie?
0 and 2.
Between the 0 and 2, or specifically negative 3 and 2, right? So we know for this one, let's write out, is there a time that does happen? Yes. V of t is continuous on the interval given initially is 0 to 12. And we want to go ahead and list out where is it? Negative 3 is less than 0, less than 2. And I would write out V of 0 is less than 0, less than V of 2. And that's strictly coming from a table. And what theorem is this? When something is in between this, what do we call that? By IVT. By the intermediate value theorem, V of t must equal 0 on the interval specific to ours is 0 to 2. And this is an AP style question. Cody, will you write everything on number 2, please? All right, for number 3, Jameson, let's read that one, please.
Use data from the table to find an approximation for the derivative of U10 and explain the meaning of the derivative in terms of the motion of the particle. Show the computation that led to your answer and indicate units of measure.
Let's underline the approximation of V prime of 10. And let's kind of write out what V prime of 10 basically means. Isn't V prime of 10 basically the acceleration? So let's write on here A of 10. To find the approximation of the acceleration, we need to first figure out where is my 10 on our t value. So when I go across, I know my 10 has to be somewhere in between. So somewhere in between, and that's why we're just approximating. It's not exact. It might be somewhat there, but not exact. So if I find the slope between the velocity, that is our acceleration. So let's write on here V of 12 minus V of 8 over 12 minus 8. And that's going to give us 5 minus 7 over 4, which is negative 1 over 2. In our units, it's going to be the following. It's going to say meters per minute squared. Do y'all need me to explain why minute squared on the bottom? You guys okay with it? Anybody want me to explain? All right, so let's move on to the bottom. And when it says to show the computation, and also I think there's explain, we have to write this in a sentence. The acceleration of the particle at t equals 10 minutes is about negative 1/2 meters per minute squared. So you'll just reiterate the original statement along with your answer. Okay, last one on this page. Andrew, let's read number 4.
Let A of t denote the acceleration of a particle at time t. Is there guaranteed to be a time t equals c in the interval 0 is less than or equal to t is less than or equal to 12, such that A of c is equal to 0? Just by your answer.
So A of c must equal 0. So it's saying my slope of the derivative must equal 0. And when they say is there a guaranteed time, typically the answer is always, always yes. So looking at this, let's see where the slope is going to give us 0, looking at our table. So on our table, our goal is to figure out if y2 minus y1 has to equal 0. Shouldn't they be the exact same number? Yeah? So where do I have the exact same number on our velocity? 2? 6 and 12. So 6 and 12 right here. Yep, that is true. So let's write out V of 12 minus V of 6 over 12 minus 6. Ooh. And that's going to give us 5 minus 5 over 6. And yes, that is 0 minute or meters per minute squared. So let's go ahead and write out some of the conditions. We know v of t is continuous and differentiable on the interval stated initially, 0 to 12. Oh, 12. And we could say yes, a of t is equal to 0 meters per minute squared. On our interval that we found was within 10 to 12, or 0 to 12, which is 6 to 12. What theorem do you think this might give us? Intermediate value theorem or mean value theorem?
You just want to write your code
Yes,
name?
that one, that's it.
Oh, okay.
Isn't it ambiguity?
Yep, by mean value theorem. Okay, let's do our third page and take a break. Oh, it's hot. All right, Landry, let's read example 2 on the very top.
The graph below represents the velocity v in feet per second of a particle moving along the x-axis over the time interval from t equals 0 to t equals 9.
Okay, so we know this one is the graph of velocity. It's not the particle. So let's write everything about the velocities, and then we'll worry about the acceleration. So as long as the graph is above 0, velocity is positive, correct? And as long as the graph is below the 0, the velocity is negative. So Jameson, we know the velocity is positive here, right? And then we know it's also positive here. How about down here? Negative. What about right here? It is at rest, but specifically, what is the y value of this point no matter what? It's always negative. But the derivative is 0. It is at rest. Now I want to look at this point right here specifically. This one is not positive or negative. The velocity is specifically equal to 0. So I want to look at the velocity alone and answer some questions until we need to get to the acceleration. So at t equals 4 seconds. So let's go to 4 seconds and go up to the graph and plot. Is my particle moving to the left or the right? So let's go back to our card. The velocity is positive, so it's going to the right. So we have, it is to the right. So you got to use your card because it wants you to explain v of 4 is positive. Okay, number 2 says, at what interval is the particle moving to the left? If something is moving to the left, what velocity do I want? Negative. So I think I'm going to highlight the negative piece right here. So I see my velocity is negative here and negative here. And maybe underline that to make it related to each other. So let's look at our domain. What is my interval at? From 5 to 9. And that is because the v of t is negative. Boom. All right. For number 3, Sam, go ahead and read number 3, please.
At t equals 4 seconds, is the acceleration of the particle positive or negative? Explain your answer.
Okay, so we need to talk about the acceleration. And we know the acceleration, just going back to our card. The velocity is the slope of the position. Acceleration is the slope of the velocity. So let's define that on here. It is a slope of the velocity. So let's go to our graph. Is my slope increasing or decreasing at this interval? Increasing. That means my acceleration is positive. And then go into the other. Is my slope increasing or decreasing at this interval? Decreasing. So let's write it is decreasing. And maybe also write it down here since it's separated by the x-axis. So at t equals 4 seconds, when t equals 4 seconds, what is our acceleration? What is our sign? Negative. So let's write on here. It says, is it positive or negative? So acceleration, ooh, my spelling, is negative because the velocity is decreasing. at t equals 4. And again, if we look at the card, the acceleration is negative because velocity is decreasing. Is it on there? Yep. Okay, let's go to number 4. Cody, let's read number 4, please.
What is the average acceleration of the particle in the interval of 2 is less than or greater than c is less than or greater than 4? Show the commutations of x and x and indicate units of measure.
So average acceleration, is that a rock or I rock? Let's write a rock. And when you're finding the average of the acceleration, it's really in the end, it's the slope of the velocity. Slope of the v. And we know our intervals that we're wanting is from 2 to 4. So let's write out our slope equation. We have v of 4 minus v of 2 over 4 minus 2. And we have our table, or the graph. What is our velocity when x equals 4? And what is our velocity when x equals 2? Is it 0? 2, yeah, 9 over 2. And that's going to give us negative 3 over 2. And our units for this one is feet per second squared. And it says to show the computation. I don't see anything with explaining, so we're good to go on this one. Okay? And then for number 5, Gianta, let's read.
Is there a guarantee to be a time t interval should is less than t is less than 4 such that v prime of t equals -3 over 2 8% squared? Specify it.
Okay, let's go ahead and circle this value right here. So v prime of t, when you were finding the derivative right off the bat, is that a rock or I rock? It is I rock. When we know the derivative at that specific location right off the bat, it is our I rock. So when I know my I rock and A rock are equivalent, aren't they equivalent from the previous one that we just did? Was that mean value theorem or intermediate value theorem? Mean value theorem. So let's write on here, we have the condition. Because justify, I need to go ahead and kind of define what that means. V of t is continuous and differentiable. And on the interval that they gave us was 2 to 4. So we could say yes. V prime of t is equivalent to negative 3 over 2 feet per second squared by the mean value theorem. So really in the end, number 4 and 5 were initially or intentionally made so that they are equivalent. Okay, last one on number 6. Milo, let's read.
At what time t in the given interval is the particle farthest to the right?
Okay, so we know the particle is moving to the right when velocity is positive. So how many locations do I have velocity that is positive on our graph? 1 here and 2 here, right? So the first one stops at what time?
3 seconds.
3 seconds. So let's put on here that was at 3 seconds. And it was moving to the right. And then we go 2 more seconds to the right at 5 seconds. And after that, it's going to go backwards. So it wants to know at what time was it furthest to the right? What time was it at?
5 seconds.
At 5 seconds.